In this video, we're going to look at finding the exact values of some trigonometric functions. And we can do that for some specific angles to go into sine, cos and tan. We can do this without a calculator, and they are going to be in terms of surds or some just fractions. And the values we can find are the ones given in this table here: 0, 30, 45, 60 and 90 degrees for sine, cos and tan. Now the first thing we can do is fill in some of the ones we know from when we looked at graphs. So for instance, the graph of sine, we know that at 0 sine is 0, and at 90 sine is 1. Cos at 0 is 1, and at 90 is 0, and tan at 0 is 0, and at 90, that's when we have the asymptote in the graph, so there is no value, it's not applicable. None, undefined, there's no value for tan. Now the way we're going to find the other three values for the three trigonometric functions is by two special triangles. And the first special triangle is an isosceles right angle triangle. So if we draw in here an isosceles right angle triangle, so here is an isosceles right angle triangle, and then we're going to say that it has side length 1 and 1, and by Pythagoras' theorem we can work out the other side length. 1 squared plus 1 squared is 2, so the other length is root 2. By Pythagoras' theorem we have got 1 squared plus 1 squared equals 2, so we have the square root of 2 is that third length. Now as this is an isosceles right angle triangle, both these angles are the same and they are both 45 degrees. So this is our special triangle, and we can work out from here now sine, cos and tan of 45. So sine of 45, well, sine is equal to the opposite over the hypotenuse. So in this case, it's 1 over root 2. So sine of 45 is 1 over root 2. Cos is equal to the adjacent over the hypotenuse. So it's equal to 1 over root 2. So it's also equal to 1 over root 2. And tan is equal to the opposite over the adjacent. So that's equal to 1 over 1. So 1 over 1 is just 1. Our second triangle is an equilateral triangle. So we're going to draw an equilateral triangle on the other side here. And in our equilateral triangle, we know that all the angles are 60. And we're going to say that the side lengths are 2. So side length is 2. And all the angles are 60 because it's equilateral. But what we're actually going to do is cut this equilateral triangle in half down the middle here to give us a right angle triangle. We're going to ignore the right hand half and just look at the left hand half. So now we have a right angle triangle with 60 degrees at the bottom. That means this top angle here is 30 degrees because of the angles in the triangle. The length at the bottom here is 1, And again, we can use Pythagoras' theorem. This time it's 2 squared plus, 2 squared equals, because 2 is the hypotenuse, 2 squared equals 1 squared plus this missing value here, or the h, height of the triangle h squared. So h squared is actually equal to 3. So here, instead of h, we can write the value which is the square root of 3. We get 4 minus 1 equals h squared. Now we have this, we can use our sine, cos and tan ratios again. So sine is opposite over hypotenuse. So for 30, when we're looking at sine of 30, the opposite is 1, and the hypotenuse is 2. So it's 1 over 2. When we're looking at 60, the opposite is root 3, and the hypotenuse is still 2. So this time it's root 3 over 2. Because when we're looking at 30, it's the adjacent, which is root 3 over the hypotenuse, which is 2. So we have root 3 over 2. And for 60, it's the adjacent, which is 1 over the hypotenuse, which is 2. So it's 1 over 2. Finally, for tan, when it's 30, the opposite is 1, and the adjacent is root 3. So it's 1 over root 3. And when it's 60, it's the other way around. The opposite is root 3, and the adjacent is 1. So it's root 3 over 1, which is just root 3. So that's how we can use two special triangles to